This is it. The investigator has officially left Hobart and we're making our way to the southern seamounts. As you can see, the weather is quite windy and a little bit wet. We're not sure what we're going to see out there and we're not sure what to expect, but we're very excited.
We are on the way to the Huon and Tasman Fracture Marine Parks, south of Tasmania. We're here to study deep-sea coral communities living on an unusually large group of underwater mountains known as seamounts. These corals are hundreds, even thousands of metres beneath us. We can't see them, so how do we know that they're there? Chief Scientist Alan Williams of CSIRO says it all begins with maps.
The first knowledge of the seamounts came from the fishing industry when they started fishing for orange roughy in the 80s. Scientific knowledge grew rapidly after that, but it had its real leap forward when we were able to map the area with multi-beam echo sounders. That wasn't until 2006.
Alan Williams has surveyed deep sea areas around Australia, and this is his second time visiting the Tasmanian seamounts.
Our survey is taking place in an area that's fairly unique globally in the sense that we have a large cluster of seamounts. These seamounts support extensive communities of corals and a very high associated biodiversity. A lot of the information that comes out of these surveys is in the form of pictures, our seabed imagery, and that has made it quite clear to everybody that there are impacts resulting from fishing. In this case, the Australian fishing industry took note of that, and a very early move was to ensure that several of the seamounts remained in pristine condition by cordoning them off in a no fishing area. Some of them have been fished, some of them have never been fished, and some of them were fished and are now protected in a marine park. And it's that contrast in fishing effort that enables us to make comparisons that should reveal the patterns of change that occur once fishing stops.
Voyages like this, which can help to tell us more about the interrelationship between marine protection and the use of the marine environment, are really important to help inform our management.
The seamount maps gave scientists clues about where to look for corals. Their next challenge is to map the coral communities right across the marine park. But with one ship and one deep camera system, this would take hundreds of years. Fortunately, there's another way. Jan Jensen from University of Tasmania knows how to bring maps to life.
Predictive mapping is the process where we combine individual observations of species or communities together with environmental maps of, for example, seafloor topography or ocean current speeds, and then analyze how these observations relate to changes in the environment, and then we use the environmental maps to produce a map of where species live. We can use these predictive maps to get a good idea about where species live without observing every square meter of the seafloor.
Jan's maps will help scientists and park managers decide where to focus future research, monitoring and protection of deep sea biodiversity. But the benefits won't end there. Nick Bax from the Marine Biodiversity Hub says predictive modelling is important to protecting valuable areas of deep sea biodiversity around the world.
Well, it's important to recognise that Australia has the third largest exclusive economic zone in the world. It's a very large area, as large as its land mass. And we've only managed to map in any detail the sea floor and possibly 5% of that area. And we've been able to go down and look at the species in that area in just a fraction of that 5%. But we need to manage the marine environment now. We need to know where we want to put marine protected areas, where oil and gas exploration should occur, where fisheries should occur, where any number of new industries might happen. So we use predictive mapping. We take the information we have in those small areas we surveyed and apply it to the rest of the country so the managers can make informed decisions on how they want to manage the sea floor around Australia.
Mapping is the first step in understanding where different animals live on the seafloor. Seafloor maps help scientists decide where to target more intensive and expensive time at sea to verify their predictions. That's where our deep sea camera systems come in.